Welcome everyone. Today we have our another new episode. We will discuss on carbon engineering, and in Malaysia we have our special day. Eid Mubarak to everyone. We have our world famous speaker, Professor David Smith, Mr. Marshall, and Professor Ching, and they will discuss about carbon engineering. First, I would like to give chance, Mr. Marshall.
Well, thank you, Sharif. Well, first of all, for all the audience members out there that have, if depending on what time zone you're in, you're either still celebrating Eid al-Fitr or about to end it. But in any case, we wish everyone out there Eid Mubarak and have hopefully the families are all enjoying the end of that celebration. Now, as Sharif pointed out, today's topic is carbon engineering, and so the question is, what is carbon engineering? And there's different takes on this depending on what side of the ledger you're on, so to speak. So, people who are very pro oil and gas and coal believe that carbon engineering has to do with taking fossil fuels and creating energy out of them, which had been done for over the past 200 years successfully, I might add, from a financial point of view for many of the companies that have done this. The issue, though, that has come about with the term carbon engineering is some people are beginning to think that carbon engineering has to do with being able to take carbon and sequester that carbon from the atmosphere, which is being able to take carbon and use it in multifold ways. Our group, who's been involved in this for the past 10 years, has discovered that there are a number of methods and technologies and natural methods to sequester carbon. And why would one sequester carbon? Why would one lead to engineering of carbon? Well, the engineering of carbon means that it's man dominated as opposed to nature. And so what are some of the things that can be done? Well, a lot of things at the beginning of the pandemic in March of 2020, the EU began a process of understanding that they needed to create what's called a circular economy. In other words, things that we all take for granted as waste can be recycled to the point where they're no longer considered waste. They're considered feedstock or supplies to create other products. And when I say products, I don't mean shoes, dresses, or other items, but products that actually continue to help reduce the environmental impacts that are out in the world today. So some of the environmental impacts that carbon engineering can affect are issues such as reducing greenhouse gas emissions. We can also improve water quality, and we can improve soil health, just as an example of the three fundamental bases of human survival. Food security through soil health, clean water, which is another means of security for the health of people, and also reducing greenhouse gas emissions so that we reduce the amount of pollution in the air and prevent health problems. Anybody that knows this, that you may even have in your own family out there, children that are starting to obtain different types of diseases and functions from breathing, and it's problematic around the world. It's developing tremendously in India, as an example. They burn a lot of rice hulls there, and those rice hulls cause a tremendous amount of pollution in the atmosphere. And just recently, there's been a publication in Iraq, as an example. Iraq has tremendous amount of pollution, air pollution that's going on. And some of it is attributed to a phenomenon known as the Khamsin, which is a sandstorm. It usually has a yellow cast to it. This one has an orange cast to it. And because it has the orange cast, we know that there are other man-made elements that are going into the atmosphere, helping to cause this problem. And it's a problem that needs to be addressed. So carbon engineering can be seen, depending on whose point of view you're taking, as something you want to have happen or something you don't want to have happen. So some people don't want humankind involved, but on the other hand, if you're going to have people performing carbon engineering, the question is to what end? Our position is what end is to improve health and air quality and soil security, which is food security and water security for people around the world. So that's the beginning of my take, Sharif. And there's much more to add, but again, wishing everybody out there Eid Mubarak.
Thank you, Mr. Marshall. Professor Ching, what you want to add for today's discussion? We are discussing on carbon engineering, and we want to
Yeah,
listen from you about this carbon engineering process.
yeah. Basically, right now I've been following this, by the way, for quite a while. You see, this seemed like an interest. It should be interesting to the world, and also for me. I'm trying to travel to China. The pollution is so bad. I wouldn't go with today's pollution. So I just follow the pollution data in China and around the world. What we are talking about carbon engineering in the latest version, it's the direct air capture. In other words, they build these large machines which captures air. Okay, eventually, they're just testing it, in Finland and also in Canada. Canada has probably one of the most advanced. I think they eventually want to transport this to China and India. So we help them capture the air. The air in Canada is Vancouver. It's clean air. There's no need for that. Finland, Finland probably have some thermal pollution, vent pollution. But it's no need. The real need will probably be in China. So it's a direct air capturing. So far, it's not cost effective. But who knows? My own feeling is this. My own feeling is uh, all this environmental problem will be solved. Probably as much by all this environmental approach as by changing the car to electric. Okay, Elon Musk is contributing, significantly in this direction. And also this other environmental system, they will also contribute. But the carbon engineering, to me, you will have, by the time it's become very useful, maybe the problem has already been eliminated. You see, because the world is moving very fast to get rid of this pollution problem, and the pollution is not good for anybody. You see, and everybody put their effort into it, and it's not such a difficult problem, so it can be eliminated. And I try to introduce an authority to our discussion, but probably too short a notice. In any case, if they show up, I would be criticizing them. You see. In my opinion, well, I'm a theoretician, so I have solved many practical problems earlier, and now I feel that the main thing is just knowledge. Doing is not really that important. Okay, the execution is not as important as to figure out the actual solution. So from a theoretical point of view, the goal of social science is to relate all the inputs to the output, one output, in a completely mathematically rigorous system, which correspond within the range of tolerance to reality. Okay, that is social science. Okay, so in other words, today everybody knows it just to collect data. All the outputs, no inputs, not a single input. When financial crisis came, and I was the only one who can predict it, because I have a complete mathematical rigorous system. The reality cannot escape this system. I just predict that it was overvalued, so it has to be, there will be a crisis. Very simple, just do 3 or 4 calculations. You predict the financial crisis, both of them, savings and loan and subprime world. So if we have some expert coming, they were talking about lots of inputs, and nobody can come up with with a system which relate the input to an output. If you don't have output, you cannot make any decisions. Okay. Also relating to this is the goal of life science is to satisfy the requirement of permanence through complete automation. Okay, that defines life science, and the social science is what we are talking about today. You know, where even if they have all this data, they cannot do it. And my friend actually is working on this tax, carbon tax. She's the author of carbon tax. So she's really on top of all these things. And I would say that I'm expressing most of my own opinion, but still the answer is the the real finally to see if justified to put money into carbon engineering. It hasn't been decided yet. There's no way to decide that. So I just try to invite people. Eventually, I also invite every time we have some subject. I would try to find the world top guy to come here if they are really, if Sheriff and I are both presentable, we will get them to give us some talk, see what they think. You see, so that's basically my my view.
Thank you, Professor Singh. Professor David
Well,
Smith. We are discussing about carbon engineering, very important topic for today's. If you share with us the process of carbon engineering and some practical projects, what's happening in North American in scientific industry with this carbon engineering project.
Sure, Sharif, I'd love to do that. Um, the carbon engineering field is growing a lot, kind of like what Marshall said. And you really see it is that it has big companies, it has small startup companies going it, and there's really several parts to this market segment. It includes the carbon capture, the carbon utilization, and really how the carbon storage is used too. Professor Cheek mentioned one of the companies in Canada that is involved, but you also see others. One of the larger ones is ExxonMobil Carbon Emissions Group. You have one called FineWorks, Global Thermostat, and others, which are really beginning to go into there. Um, this market began to come into its own really back in around 2017. And you see uh, a lot of projects working in a lot of different areas as you look at it. Um, it is broken down into a lot of subsets into it, though. And as Marshall said, one of them is removing the carbon uh, from the free air. Others is trying to remove the carbon by scrubbers and things earlier into the process. The marketplace is really moving quite a bit higher as we see it going, because out of the early COPs, there was carbon offsets, and that has really moved on into saying, well, how do we actively work to remove the carbon from the air? How can we go out in places independent of the manufacturing process, independent of the pollution process, and begin to do it? So you see some in Canada, United States, you see in the Middle East, uh, quite a few collections of these large fans that are pulling air through the intake where they're beginning to be containerized. Then it goes to a separate process in it where it begins to do it. You see ones which are looking at storing it. You see some which are looking at converting it to other uses. Um, and you see a lot of the carbon beginning to be used compressed and beginning to use in other technologies. And why does it matter? Like you say, the market numbers kind of say that for every ton of carbon you capture there and use in others, it's about $600 per ton as the cost to remove that. So it's still expensive, but it's beginning to show yet another way to take care of the carbon in the air and reduce the global gas environment. But it still has costs. It still needs to be able to scale larger. The works are still coming. So you asked the question on the companies, really. United States, it's being used in Europe, China, like I said, UAE is beginning to use it quite a bit. Japan has projects in it. There's a project in it in Brazil, in Colombia, and you're seeing it beginning to be deployed. There's a new pilot project underway in India that looks real interesting, but it's a market that's still developing, and that the cost structure is still trying to work it out in a way to make it more affordable, so that more can be deployed, so it can have a larger impact. But that's the kind of the market size of it right now, Sharif.
Thank you, Professor Paul. You are a climate change activist, and you have vast knowledge about climate change related issues. Carbon engineering is a very important, with some practical example from the industries. What is happening through this carbon engineering process in North America? If you share your views, it will be helpful for our audience.
Okay, well, all of the work up to now and in the near-term future is very small potatoes. It's if you look at the overall amount of carbon it's removing compared to what we're putting in the atmosphere, it's just a very, very small, tiny subfraction. So what we really need to do in order to address the climate crisis is to have something that is very scalable and low cost, and but scalability is the most important thing. Can we scale it up to take out vast, huge amounts of carbon from the atmosphere? And I would argue, if I was in charge of the situation, I would argue that it's far easier to remove carbon from the ocean than it is from the atmosphere. There's various, and also use nature, just enhance natural biological processes. So there's a very interesting, promising technique called iron salt aerosols. And the idea is that you put these iron salts into the atmosphere over the ocean at very, very low concentrations. And the actual, while they're in the marine boundary layer, they are carried by natural convection up to, and they generate, they seed clouds. They act as cloud condensation nuclei for low-level clouds, low-level marine clouds, which block some sunlight and cause some cooling. And the iron, eventually they settle into the ocean, and they're in the ocean at very, very low concentrations, but the iron is sufficient to seed the growth of phytoplankton. So they get phytoplankton at the surface in large quantities, because many areas of the ocean are high nutrient, low iron regions, and iron is a missing nutrient. So very, very small quantities of iron are sufficient to stimulate phytoplankton blooms, because it's the only missing ingredient. And those blooms not produce oxygen and capture carbon. As the phytoplankton is eaten by zooplankton and even ingested by fish, it's excreted out, a lot of it, and sinks to the bottom of the ocean floor, where it re-enters into the sediments. So it removes the carbon from the atmosphere ocean system. If we remove carbon from the ocean, right, there's a dynamic balance between the atmosphere and ocean. So if we were to remove carbon from the ocean, as I've mentioned, then the levels in the atmosphere would also drop. So it's good to not just consider, and we need to consider all possible engineering methods. Direct air capture has been mentioned, and look at all methods and try to, see which ones are most cost effective and most scalable. And I would put my money on something like iron salt aerosols as opposed to any of these other direct capture methods. I've also talked about the necessity of taking sort of a three-legged bar stool approach to climate, and that is, oh, the other thing about these iron salt aerosols is that they do break down methane, and they convert methane to CO2. So that's a very, that's a very good thing for climate, because the global warming potential of methane is much larger than that of CO2, and the concentrations of CO2 of methane are much, much lower. They're parts per billion as opposed to parts per million for CO2. So when the methane is broken down into CO2, there is the constant, it has a huge climate benefit. So, but I've also talked about, like I said, the three-legged sort of approach. We need to slash fossil fuel emissions. We can't forget that we need to slash fossil fuel emissions, and to do that, we need to get rid of fossil fuel subsidies. It's just simple economics. We need to do the carbon dioxide removal from the atmosphere ocean system before the climate gets more destabilized, and we need to look at ways to we need to look at solar radiation management methods as well to block some of the incoming sunlight. So the thing I like about the iron salt aerosol method is it does both solar radiation management and carbon dioxide removal, and also methane removal. So it's well worth looking at. I've done a few videos recently on it, and I've got a couple really technical papers on it, which I'll be going into in some near-term videos that I produce for my video channel. So yeah, so that's my views on it at the moment.
Thank you, Professor Paul. I have more questions, especially I believe that it will be very interesting for audience. How do engineers use carbon, and how much does a carbon engineer plan to cost? Because cost is very important in present situation. Mr. Marshall, what you want to add for these two questions?
Well, to answer your two questions, Sharif, we need to take a step backward and understand the term carbon engineering. Generally, it refers to greenhouse gas removal, GHG emissions, greenhouse gas, which is composed of other gases besides CO2, besides carbon. So carbon has the dominant viewpoint for most people out there that are not in the science, as Paul is. And as Paul pointed out, he's got a very approachable and significant approach to reducing carbon in the atmosphere. And I think the ocean component of that is really important, the way he described it. One of my good friends, Brian von Hurtson, just received the X Prize with his efforts in ocean mitigation of removal of carbon from the atmosphere and demineralization process in the oceans, which is also contributing to that. So the term green carbon engineering has a broad expanse. The other method that people are talking about, there's two other methods, is direct air capture. And I think that's what David Smith was referring to in some of his topics, and so is Hugh. So direct air capture is a process of capturing carbon dioxide, CO2, directly from the ambient air, as opposed to capturing it from point sources, such as cement or biomass power plants and things like that. So there's a lot of effort going on. It's captured the news that DAC or direct air capture is in the news right now, having to do with carbon engineering. Another point of carbon engineering is the one that we're involved in, which is getting several birds with one stone, as we like to say the expression. One is some of those several birds are formulated in the Sustainability Development Goals of the United Nations, the SDGs, and there are 17 goals. One of them is obviously to improve education of people, which is what the World Talent Economy Forum is heavily involved in, and is a significant contributor to that SDG. There's also the elimination of poverty. But one of the things that helps to eliminate poverty is that if we take a circular economy approach and take waste and we convert it thermally and through other means into products that reduce greenhouse gas emissions, improve soil health, as I mentioned in my first round, and these other things. So to give a classic example of what you're asking about, Sharif, is the fact that there is and it just came out, there's a video on it that was produced by the International Biochar Initiative, and I think in conjunction with the Australian and New Zealand Biochar Initiative group, about how we take waste, thermal organic waste, and convert it into a material known as biochar. That biochar material can sequester carbon at great rates. It has high porosity, meaning it's able to adsorb a lot of material. And that adsorption capacity sequesters carbon in many ways, many ways. So it's not just a classic example is the charcrete or the biochar cement approach. And we know that when it's produced, and there's been studies done in Europe and also in Asia, when the studies demonstrate and show that when you can capture carbon out of the atmosphere and sequester it for hundreds of years. It's used to pave roads. They're doing that in Australia. They take macadam, which is the material that is bitumen that is used to create paving of roads, asphalt, and they blend it with this biochar, and it sequesters carbon for a long time. That's a classic example that's just starting to take off and get its legs, in addition to the ocean opportunities that Paul was talking about. So another example of that is charcrete, which is where you take high carbon chars that are formulated from waste materials, organic waste, not from cutting down trees. You want the trees to be out there because that's a natural way of sequestering carbon. The more forests you have, the more tropical forests that we have, the better it is for people to sequester carbon. Another component besides the charcrete, by the way, Sharif, is another capability to take biochar, and if it's high carbon, 60% or above carbon, low ash content, no heavy metals in it, and the right pH level, it can actually act as a soil amendment and create carbon and sequester carbon in the soil for thousands of years, not hundreds of years, like the building material. So the more we sequester carbon these different ways, the better it is. So you have the direct air capture capability. That's trying to use technology to take ambient air and, as opposed to capturing it, like I said, from the point sources such as biochar. By the way, Sharif, one of the ways that our listeners might want to track some of this material, there's two things I'm going to give them. The one is the Intergovernmental Panel on Climate Change. It's known as IPCC. It is the leading world-dominated world of agency, and it's a body of the United Nations. It's responsible for advancing knowledge on human-induced climate change. And it was established in 1988, and it was established by the World Meteorological Organization. That's a mouthful, isn't it? And the United Nations Environmental Program. And then it was finally endorsed by the entire United Nations General Assembly, headquartered not in New York, but the one in Geneva. So it's based out of Geneva. It's composed of 195 member states, and I believe Malaysia is one of the members, just for everybody's edification. In addition to that, IPCC publishes a lot of reports. They just reported in February and also April. The April report was very scary, but hopeful at the same time. It gave news that reducing greenhouse gas emissions is a primary goal for the world, to be able to improve that the temperature of the Earth will remain within an area that will not cause human suffering. And I'm not going to go into the numbers. We could talk about that. You can look it up. But basically, there's the IPCC, and then the other one that I would like to tell you about is that if people go to, there's an organization that people can drop into and help participate in, just as you don't have to be an expert in the field. It's called Drawdown, DRAWDOWN.org. Drawdown.org is an organization that it's not for profit, and it has events and news. It has videos that share how you can participate in drawing down carbon and CO2 out of the atmosphere. And it's part of that carbon engineering construct that we're talking about today. Everybody can play a role in this. You don't have to be a scientist. You don't have to have the expertise. Everybody has a role and can participate in one form or another. But time is of the essence. We know this from based on the science reports, and I encourage that people support Paul's efforts and other efforts like my buddy Brian von Hurtson from the Climate Foundation, whose mission is to focused on, in their case, Paul and Brian are focused on ocean, but there's also land-based solutions as well. It's a broad expanse and it's a broad topic, and we want everybody to participate as much as possible.
Thank you. Thank you for your explained analysis, Mr. Hurtson. In terms of this carbon-related technology, what are the technology that will be helpful for developing world? Like here is price is very important. How you want to share some of the specific technology you want with our audience?
Okay, basically, you see, this fossil fuel will last. They always say last 50 more years. Okay, it's been many 50 more years up to now, but it's not a permanent solution for energy. So I follow nuclear engineering very closely because I am a nuclear engineer by training, plus my control fusion. So I think eventually this competition, the time is of essence. You see, fossil fuel will last 50 years. And the nuclear energy, when you produce too much, the Earth can only take so much energy. Okay. So, my feeling is we keep talking about this carbon engineering. What does carbon got to do with nuclear engineering? Okay, the big picture seems to be, is whoever is talking is working on the subject that seems to be the most important. And I'm not one way or the other. I'm just feel the social science problem not solved. So we cannot really decide the value of either, fossil fuel or nuclear energy. So basically, the environmental crisis is a survival problem of limited complexity. It's a permanent problem. So I would definitely encourage people to look into that. Okay, young people, they can devote their lifetime to this environmental crisis. Okay, and also on the sequestering of carbon, most advanced people, according to Australian, are in the US. And Australians are the most interested in sequestering carbon because, they got all this land. They need to make them work for them. So, and also one of the most pertinent problems, you see, we keep talking about different things. Okay, for us, for me, as the founder of Pole Science, I will face the fact. Okay, I look at all things. Okay, and make a judgment. What we need to face, but are not, is the fact that most pollutions come from China. Okay. So all these things, you put it together, it seems like it distort all this technical discussion we have. You see. And I think people here are really expert. I would really invite them to join force with me. I have so many people come to ask me to let them allow to use my reputation, my name. I would do so, provided they can show me that they they can do something for me in return. Not doing something for me in return. I would test them. Okay, like students when they come, I would test them. If they pass the test, then I would do things for them. I brought some of them over to the US. Okay, Sheriff is laughing. So I would test them. Okay, so people here, Marshall, Paul, and David, if you people have some kind of, academic credential or industrial credential, maybe, those people who come to me, I will recommend you to them because you are very experienced in all subjects, which is surprising to me. I read a lot, but I only try to find out who's the most experienced so I can introduce the sheriff. We have some guys who's the leader in the field, so we can all try to figure out some way to attack him. So basically, that's what I feel that my views. Okay, so it may not be
Thank you.
totally
Thank you.
on the subject of carbon engineering.
Thank you, Professor. Professor David Smith, in the industrial area, like from the corporations, actually, who is the leader who actually invent this carbon related technology, like carbon engineering related technology, and who is producing and who actually market it?
As was said earlier, one of the leaders is this Canadian company called just Climate Engineering, but then others like Exxon Mobil, Spaghetti, there's about half a dozen others. One of the interesting developments in this area is very recently, Elon Musk just pledged $100 million to advance carbon capture technology. You also seen Microsoft, United Airlines, and others make billion-dollar investments in the field of carbon capture. What you have up on the screen, Sharif, are some of the existing plants you see, where the one in the upper left is actually being built out in West Texas right now in one of the oil fields. It is being used to pull it back over. The one in the bottom right is the prototype plant for carbon capture that is beginning to pull out. And you see others of this same type of approach there. But the key things of this type is that it's actually used there to pull the air through the units. And what it does is it goes across a filter, which is drenched in potassium hydroxide solution, which is also known as potash. And what it does is this potash absorbs the CO2 from the air, after which the liquid is piped to another chamber where a calcium hydroxide, which is builder's lime, is used, and it takes hold of the CO2, which is producing small flakes of limestone. Then these are shreved off and heated in a third chamber where they decompose and they give off pure CO2 there, which is captured and stored. So what you see there is it is a multi-stage process that it takes to capture this air and be able to use it. Also, this is the vision of a larger plant that is going to be built in West Texas. And you can see that from the small number of fans there and the small containers and the small furnaces, it's a vision to be much larger. And this size will begin to be able to make an impact because it's where we are right now, there's not a lot of being taken out. We currently generate about 36 gigatons of carbon per year, and what the goal is to be able to generate plants that each plant would be able to pull about 10% of that out and be able to get it down. The goal is to get the capture rate for these plants down to about $94 a ton of full fabric coming out of it. So there's a lot to be done in this area. Uh, the the estimates suggest that we need to have about 30,000 of the industrial cell size plants to do these spattered out throughout the entire world. And that to do that, it's going to take a lot of work. The other thing that we see here is we cannot just rely on this. Again, it's going to be an approach uh, to where it will take many things. And one of the other things that came out of COPS is uh, we need to reduce the outputs as we see through electric vehicles and others. Another part of it, though, is real interesting, is there is now renewed interest in planting more trees uh, and in restoring peatland, of changing the amount of green plants and things around. So again, what we need to do is uh, put all these elements together, do climate carbon reduction, do climate carbon transformation, and to have the ability to control this through a better understanding. And as we've said before, not just regionally, but globally. This is a set of change that has to happen globally. And we need to go ahead and begin to put in place the opportunity to go ahead and take these technologies, develop new technologies. There's some very promising new technologies at universities like Purdue. There's some promising technologies that are being put in place over at Cambridge, uh, and some others to do this types of carbon capture. But it needs to be done at scale to have a true impact. Sharif, that's kind of, I think, answers your question.
Yeah. Excellent, excellent, Professor David Smith. I really appreciate your effort. I request all of our audience, especially the youth community, those who work with us in School of Talent Economy, regularly before the session, we take the class. So I request, like our students, you can develop some case study based on Professor David Smith and our other speaker sessions. It will help you to understand more about carbon engineering, and most important things, when you conceptualized this thought, and when you actually share your thought with your schools, with your government or corporation, it will be more effective for all of us. Professor Paul, what you want to add about this, the efficiency of carbon capturing? What do you think? This is a effective technology, efficient technology, and in the near future, how the developing world, yes, for developed world, they are rich, they have money, they invest a lot of money for this kind of research, so they can get the benefit. But the developing world, how they can get in to this kind of technological innovation?
Well, the as Marshall was talking about Brian von Hertzen, he's a very interesting, done some very interesting work over the years with in this field with carbon capture without on shoestring budgets for the most part. I mean, one thing that I am one thing I recall that he did a while back was, and you can find a YouTube video showing how it works, etc. But he used these very long cylindrical pipes, which were, hanging vertical in the ocean, and the entrance of the pipe at the surface was, say, a couple meters below the surface, and they would extend down, 100 meters or more, and there was a valve at the bottom, and basically it was tethered to a floating buoy, and it operated by wave action. So what it actually did is, as the crest of a wave came by, it lifted the whole apparatus up. The valve at the bottom would shut, and as the whole apparatus was lifted upwards, it would bring a plug of water from deep below up the pipe, a few meters with that wave, and then as the trough of the wave hit the device, it would lower back down. The one-way valve would open, and it would recharge with another plug of cold water. And so by the wave action, it basically brought water up from deep down up towards the surface over time, with just being powered, the motion of the movement of the water coming upwards just being powered by the wave action. And what that would do is the water deep down is laden with nutrients of all sorts, and those nutrients would be brought up to the surface where it would stimulate phytoplankton blooms. And once you had the phytoplankton blooms stimulated, then the zooplankton would appear to eat them, and you go up the food chain, different types of fish, larger and larger fish. Eventually, you had a whole marine ecosystem in that region of this device, and that marine ecosystem actually represented a large capture of carbon from the atmosphere ocean system. So that was just one example, and then there were some other things that his company did, were involved putting these pipes from deeper in the ocean, fixed pipes from deep in the ocean to coastlines of small islands and things, and that would stimulate the fishing industry, because it would stimulate the marine ecosystem around that location. So there's lots of different ideas that we can do to capture carbon. I mean, you can go the pure, engineering technology approach, where you build machines to, do direct air capture using chemical sorbents and of course the trick there is, that's difficult to do, because the concentration of CO2 in the atmosphere is relatively low. It's only about 420 parts per million. It's low from an engineering standpoint when you're trying to remove it from the atmosphere. You can go to point sources where carbon is being produced, like in coal burning power plants, et cetera, and then try to, the carbon, the CO2 in those situations is a much higher concentration, so it's energetically it's easier to remove than the direct air capture machines. But again, nature is very, very good at capturing carbon. We can just help it along, and that's what when I talk about the most promising, in my opinion, ways and scalable ways to remove carbon from the atmosphere. I'd like to really use nature. It's under the idea of biomimicry, if you like, or natural process enhancement is what we're talking about, as opposed to building a completely, basically when these direct air capture. I mean, what's better at direct air capture than plants? I mean, we're building, when we build a direct air capture machine with the fans and chemical sorbents, et cetera, we're actually building, a huge artificial tree, if you like. So, if we can stimulate the growth of plants and plankton and things like that, we can do it directly using nature, as opposed to building a big fancy machine. So anyway, those are just some ideas. I highly recommend people educate themselves onto what these iron salt aerosol, what this process can actually do, because it's quite interesting. And there's lots of other ideas, but I was, if I was to bet on which horse would win the race, that's probably one of them that I would pick. Also, there's a lot of interesting carbon capture work that's been mentioned that's being done in Iceland, where I think that's Climeworks, where they're actually taking the carbon and they're injecting it deep into the ground, into some of these. There's lots of geothermal energy. There's lots of fissures, and you can inject it deep into the ground. And they measure the CO2 coming out, and they find that the CO2 is very quickly converted, in some cases in less than a year, from the gaseous form to rock. So basically, you inject it deep underground, it reacts, and it becomes part of the minerals and rocks deep under the ground, and very little CO2 comes out the other end. So you know it's being captured. So there's lots of there's the two problems, of course. How do you remove it from the atmosphere or ocean system, and how do you store it? Where does it end up? And if you're doing it with phytoplankton in the ocean, it ends up in the sediments on the ocean floor eventually, where it's sequestered for long periods of time. So again, there's lots of different ideas, but what the field is lacking is significant amounts of money. So there's lots of little projects going on. There is more money coming in. Things like the X Prize help, but we need to get if fossil fuel companies became, if they were forced to spend some of their money to ensure that their the carbon sequestration happens at a very, very large scale, then that would go a long way into removing carbon from the atmosphere ocean system. And but right now we're doing the opposite. I mean, we're subsidizing fossil fuel companies to the tune of billions upon billions of dollars a year to remove carbon from the Earth system, from the ground, through mining, whether it be natural gas, oil, coal. We're still funding them to huge amounts of subsidies to remove carbon from the Earth system. Instead of those subsidies need to be to put the money back, to put the carbon back into the ground, into the Earth system, not to remove it and bring it up into the atmosphere ocean system. So we're still heading the wrong way with these subsidies for fossil fuels.
Thank you, Professor Paul, for your excellent analysis. Yes, you know that World Talent Economy Forum, we work as an academy, and we are improving every moment. Because of the huge demand from the academic side, we are publishing our book. I request our speaker, I know they are very, very knowledgeable person. They have experience from academy, from industries. So if you want to write a book chapters, our issue is the economics of talent management and capitals, and it will be published in IGI Global. It's one of the famous publishers from USA. So those who are interested from our speakers, because your contribution will be valuable for us, you can publish chapters, at least one book chapters, you can share with us. Actually, our date is June 15, proposal submission deadline, June 29, notification of acceptance, October 13, full chapter submission. So you have enough time to submit your chapters, and it's a peer review process. And through this peer review process, I am sure that we can contribute more in the knowledge-based society. And this kind of projects actually helpful for our students, for our communities. We are trying to developing in knowledge-based communities, and definitely we are focusing with our initiative, and definitely we are advocate for modern science, engineering, and technology. And talent economy is our main objective. We want to develop more talents, more effective strategy we want to take. And beside that, I want to share that we are taking more interesting initiative, like we want to develop our lab. So those who want to share your views or share your knowledge with our lab, you can work with World Talent Economy Forum. And also I just want to share, already I share with you that World Talent Economy Forum, like beside this dialogue, before every dialogue, every topic we actually discuss through this channel. This is School of Talent Economy, and all of the interesting topic we are discussing now before this sessions we actually share with our students. So from our speakers, those who want to be volunteer for this School of Talent Economy, those who want to contribute through the class, it will be more like a class. So you can share your presentation. You can take minimum 15 minutes or maximum 30-minute class. So you can join in our initiative. And good news already I share with you that World Talent Economy Forums actually nominate by uh, Van Future Foundation for our contributions for the developing worlds. So we need more contributions. We need more support. Even different universities from developing world, they are collaborating with us. Today, I get call from Dhaka University, one of the largest university in Bangladesh. Their chancellors, their vice chancellors, and their head of business school and computer science department, they want to do what we are doing, same kind of conference in Dhaka University. For perhaps the prime minister of the country, she will join in our conference. So this kind of knowledge-based initiative, we are trying to helping the community in India. We are helping 30,000 students for developing the grassroots level initiative. We are developing the universities, and we are helping the university more attractive, more reliable, and more effective for them. So that is the way we actually helping the grassroots level people. Yes, we have limitations, but we have big hearts, like all of our speakers who want to support the global community. So I request all of your more support, because we are growing very fast, perhaps one of the fastest growing think tank in Asia Pacific. And we are getting more support from the government, from the central bank, from the think tank, from the foundation, university, research organization, largest corporation, startup ecosystem, everybody joining in World Talent Economy Forum. So your effort is priceless. All of your effort, especially our speakers' effort, is priceless. So I want more of your contribution, because we have a big dream. Your contribution can help us to achieve our objective. Now I directly want to go for the concluding remarks. First, I want to give chance Mr. Marshall.
Well, thank you, Sharif. This has been a fascinating topic, carbon engineering. And of course, I'd like to announce today that we will be submitting our submission to the book, and continue to support the efforts of the World Talent Economy Forum in many different ways. And we'll hopefully continue this partnership and move forward, which segues to some of my concluding remarks on carbon engineering. The World Talent Economy Forum and our group have formed, and a lot of the panelists here are involved, in working together with people on the ground in Malaysia to be able to take different types of waste and convert them at scale. This is not the ocean component that Paul's doing, but we need to think about that as well. I have direct connections with Brian von Hurtson, and also knowing Paul as well, I think we can make efforts and headway and gather the kind of financial support to get that done, and we'll need to talk about that. One of the things that we're able to do through the efforts we're providing is we're able to get large amounts of money supported through the Climate Bond Initiative in the EU. We're pursuing that right now. This is an infrastructure lift, lots of money supported by investors or people who buy bonds in Europe and around the world. And that supports the efforts to take the tangible ability to take some of the technology that we have. We have 4 different technologies that can sequester carbon, clean up the air, improve soil health, and at the same time improve and reduce diseases, zoonotic diseases, the kind we've seen around the world recently. So one of those efforts is we're going to be bringing what's called a pyrolysis system. Pyrolysis is burning in the absence of oxygen. It's not gasification, it's not incineration, which uses a lot of oxygen, nor is it torrefaction systems. But these are systems normally are scaled up to 10 metric tons a day of waste. Ours are 12x that. They're 120 metric tons, and they convert into a material known as biochar, which is a carbon sequestration tool that can be used in many ways. Depending on its feedstock, it could be used in sequestering and improving soil health. It could also be used in producing capabilities to, like I said, bioconcrete or biochar concrete, or charcrete as it's called, and that can last for a long, long time period. We did a study of that in Europe, which we showed that it was 30% lighter than reinforced concrete and 100% stronger than reinforced concrete, and could withstand a lot of temperatures and cracking. The other ability about it is that it stores the carbon in the structures, in tunnels, bridges, and things like that, which are really a great way to improve the infrastructure around the world. And to answer Sharif's question, I think, which is the most telling question, how does carbon engineering help the developed world? And that is where we are teaming up, and a lot of the people on this call, on this panel, are teaming up, and along with other people we've had on the panel, to create this carbon engineering approach that now most people, when they think of carbon engineering, it's carbon dioxide removal, also known as CDR. And that's a negative carbon CO2 requirement. And that's what we need. We don't need net zero, which means it's at zero. We need to go below net zero and be carbon negative. And I believe Paul's efforts and those of the other people that are involved, like with Brian in the ocean, that's a big opportunity, and we need to follow up on that. And we will be having more conversations. And I would like to see a whole topic on ocean capabilities that Paul leads us on, and maybe we can get Brian to participate as well. There's other opportunities too that I know that David Smith and I have been working on together with Sharif, as I said, on the land-based capability to take waste, and make it so that there is no such thing as waste anymore. That it is actually a supply chain to take human waste and crop waste, crop residues, and then also the plastics and textiles that people are man-made, that come, by the way, from fossil fuels, and that we can convert those into materials that can actually lower the carbon footprint of humans, and at the same time improve carbon sequestration and improve the quality of life of people. So I'm talking at the broad level, and I want everybody out there to contact Sharif, to get in touch with them, see what they can do, ask questions, participate in the program, submit a paper like we're going to do, and also participate in this program. Everybody, we need, as we say in sailing, all hands on deck. Everybody has to participate in it. Time is of the essence because the climate clock is ticking down, and we need to act as soon as possible. And it is our belief, everybody that's part of the World Talent Economy Forum, that the World Talent Economy Forum is taking the lead for the developing world, to make opportunities for the developing world, to increase opportunities through jobs, education, and lowering of poverty, and meeting those 17 Sustainability Development Goals stipulated by the UN, and also be able to integrate the goals of the IPCC, the International Government Panel on Climate Change. So I request everybody, please support Sharif and his efforts, and thank you very much for having this, Sharif. It's been an important topic.
Thank you, Mr. Marshall. Professor Ching, what's your concluding remarks for today?
Okay, well, you see, the developing world should learn from the current advanced nations to see what they did is right or wrong. Okay, I second the Marshall and Paul's idea, especially Paul's idea that well, nature has its way. Okay, and in many circumstances, we should be supporting nature instead of trying to replace it. Okay, so for most people here, we are very polite. Okay, for me, I'm not really that polite, especially in a conference. Have a face-to-face discussion. Okay, I would openly say that humans are not the most intelligent in the universe. Okay, there are two intelligent systems related immediately to many of our discussion. The first is the human body. Okay, every day, every week I go dancing. I got level. I don't know if you understand this, level 1, level 2 injury. I got some injury, level 0, level 1 injury. I don't go for level 2 injury, but that could be more troublesome. and the human body heals, okay, itself. Okay, I don't think any doctor can do any better. Okay, we human move very slowly. The cells in your body move so fast. You cannot really follow them with naked eyes. You see, so it's so intelligent. The human body is so intelligent. If you trust that your health will be much, well, I would say will be natural and much better. Another thing that's very intelligent is the environment. Okay, if you look at some of the video people take, especially in Australia, they have lots of money. They want to do the big thing. They look from the overall picture. They take picture of the weather. Okay, every year, the weather clean out the earth. Okay, if the weather didn't do it, no matter how much work we put into it, it's not going to do anything good. Okay, Paul's idea of going to ocean and the revive the ocean ecosystem, that's great. Okay, that is, you need that all the time. Okay, anything that can improve, can give some help to the environment. In other words, when you're sick, you need to give some help to your body to cure yourself. You don't cure yourself. You give help. Okay, so this environment is same thing. We try to provide help to get this very intelligent system, this system which we don't understand as humans, some help. Okay, just let them do their work. Okay, there is a wisdom in the universe which today scientists do not embrace. They're against all that, and I'm the founder of pole science. So I'm against them if they have their view. Okay, so I do take my view. You see. So that's my conclusion.
Thank you. Thank you, Professor David Smith. What's your concluding remarks for today's session?
Sharif, thank you again so much for allowing me to be part of this. This is a topic that's very important to the entire world. And it's a topic that's important for universities to help teach, for the schools to help produce qualified graduates, to help expand the art of what's possible in this whole climate remediation area. We mentioned earlier that this is also a business opportunity for people. The technology is beginning to be more refined. We see new advances coming out. Most of the implementations of this technology are going to be regional, which again opens the ground for entrepreneurship and is one that this technology works great in developing nations and in developed nations as well as you see it. Paul's approach with water, I wholeheartedly agree. I agree with also the approaches we see in improving the technologies we have at other places where the carbon is generated from, to be able to scrub it at point of use too, to increase the viability of it not being released to the atmosphere. I again want to put into play here is that, as we see so often in some of the topics that you choose, Sharif, this problem set is also a system of systems problem set. We have to change multiple things in the systems to have an effect. We have to begin to work not at one point, but across all these points to have the impact that we desire to have in the global environment, the global ecosystem. And we all have to do our part. So Sharif, thank you so much for allowing me again to be part
Thank
of
you,
this.
Professor. Thank you, Professor, for your continuous support. Professor Paul, what's your concluding remarks for today?
I'll echo everybody else and say thank you, Sharif, for setting up these sessions, and thank you to all the panelists for great comments and insights. And I'll just reiterate what I said. What I've been saying is that the oceans are 70% of the land surface are the oceans, and as landlubbers, the human species tends to focus on what we can do on the land surfaces where we live, and we can't ignore the oceans. We have to remember that the vitality and life in the oceans is essential to maintain and restore. And life basically couldn't live on the land without life in the oceans. And the biomass of animals and plants in the ocean has greatly reduced. Even in the last century, large fish in the ocean, we've lost 90% of them. So by using methods to enhance the base of the food chain, which is the phytoplankton in the ocean, we could get lots of carbon capture, and we could build up the biomass of the living ocean. And I used to, as growing up, Jacques Cousteau and his explorations with his ship, the Calypso, around the oceans, studying the oceans, got me really inspired about the vitality and the immensity of the oceans. And there was probably a lot more interest, it seems to me, in the public sphere on oceans. I mean, in the 70s, the U.S. had the Sea Lab experiments going on, or Sea Lab habitats. They had off Florida in the shallow waters. They had They had equipment where people would live for months on end on the ocean floor, or weeks on end anyway. And those sort of things all ended, and there were lots of back when there were very few television channels, people would have, they'd watch these particular shows, and there were many on the oceans at that time, and now, of course, people, have no commonality in what they watch. There's so many different avenues of entertainment, and videos, etc., that people, they've lost some sort of commonality in, and therefore, it's up to individuals to have their own filters as to what's important and what's not. And I think we've lost something with all of this extra choice, and we've lost this sort of these common goals to ensure that our environmental ecosystems and our planet maintains its vitality. So we have a lot of sort of inner thinking and to do, and we have to really consider what's important. We've lost sight of what's important, of how important these ecosystems are to our survival on this planet. So I think education on what we're losing in terms of our the vitality of life support systems on our planet is very important. So shows like this are excellent, and I think there's we can't lose sight of the fact that we don't have unlimited time to come up with solutions and things. The climate is rapidly changing. The overall system is changing. We're getting lots more extreme weather events around the planet. Look at the heat waves going on in India and Pakistan, for example. We're reaching limits of human tolerance for heat and humidity on the planet, in terms of wet bulb temperatures and things. So we don't have time. We're in a crisis, and we need to look at ways to remove carbon from the atmosphere ocean system, to provide some cooling to the planet, and to slash fossil fuels, and get rid of fossil fuel subsidies. So we have a lot of work on our plate, and we need to start, we need strong action to try to stabilize our climate system so that we have a future on this planet. So thanks again, Sharif, for all your efforts and work, and to the other panelists as well.
Thank you. This is excellent session, especially through this process we can create awareness. we can engage with a lot more people. So I request all of our audience, please share our content with your government, with your corporation, and with academy. And hopefully through this process, we can learn more, we can understand more, and we can take more initiative. Thank you, Mr. Marshall, Professor Chin, Professor David Smith, and Professor Paul for your continuous support for World Talent Economy Forum. Thank you, bye-bye, and take care.
Bye-bye, Sharif. Bye-bye, everyone.
Bye.
Bye, y'all.